Hello students, welcome to my mathematics class. Today we will discuss some more questions and some more concepts about differentiation. Okay. First of all, we discuss some formulas related to differentiation, which are derivative of trigonometric functions, derivative of inverse trigonometric functions, derivative of log functions, derivative of exponential functions. Okay, trigonometric ratios are six, which are sine, cos, tan, cot, secant, and cosecant. Okay, so first of all, derivative of sine x is cos x, and the derivative of cos x is minus sine x. Derivative of tan x is secant square x, and the derivative of cot x is minus cosecant square x. Derivative of secant x is secant x into tan x. The derivative of cosecant x is minus cosecant x into cot x. Derivative of inverse trigonometric functions, derivative of sine inverse x is 1 by under root 1 minus x square. Derivative of cos inverse x is minus 1 by root of 1 minus x square. The derivative of tan inverse x is 1 by 1 plus x square. Derivative of cot inverse x is minus 1 by 1 plus x square. Derivative of secant inverse x is 1 by x into root of x square minus 1. Derivative of cosecant inverse x is minus 1 by x into root of x square minus 1. Okay, listen students, one important thing about inverse trigonometric functions, the derivative of sine inverse x and cos inverse x shows additive inverse property. It means the sum of the derivative of sine inverse x and cos inverse x gives 0 as a result. Okay, similarly tan inverse x and cot inverse x also shows additive inverse property, and the secant inverse x and cosecant inverse x also shows additive inverse property. Next, derivative of log functions. We directly differentiate those logarithm functions which are in natural log. Natural log means the base must be e. Okay, here e stands for exponent. So derivative of log x is 1 by x. Okay, and the derivative of ln x, ln is natural log. Okay, there is no need to show a base. Okay, as in this concept log ex. Okay, while in this concept we are no need to take or show base e. Okay, so derivative of log x is 1 by x. If you want to differentiate a log function which not contain x, but other than x, like x square minus 1, sine x, tan x, or any other functions. Okay, so the result is 1 by function multiply by derivative of that function. Okay, we further discuss this concept in our questions. Now derivative of exponential function. Exponential functions are those in which power is a variable, okay, to a constant base. So derivative of e raised to the power x is e raised to the power x, and the derivative of a raised to the power x is a raised to the power x into log a. Okay, and the derivative of e raised to the power function, any function other than x, is in the form of e raised to the function dot derivative of that function. Okay, we want to differentiate a function which consists of power 1 by 2 or root. Okay, then the derivative of this kind of function is 1 by 2 root function into derivative of a function. Okay, now we discuss some important laws related to log x into y. Here two different functions are taken as a product, okay, with log. So the expand form of this kind is log x plus log y. Okay, and when the two functions are in fraction form, then we use a negative sign. It means log x minus log y. Okay, if the given function in the form of log x raised to the power y, then we write y log x. Okay, so here is a list of some important formulas related to differentiation which are used in chapter number 5, differentiation. Okay, now let's take some examples related to differentiation. Okay, so first question is this, question number 1. Okay, differentiate e raised to the power sine inverse x. This is the second question of exercise number 5.4 NCRT textbook. E raised to the power sine inverse x. So with respect to x, complete question is this, with respect to x. So solution. Listen, our solution will start, always will start with respect line let y, okay, is equal to e raised to the power sine inverse x or any given function. Okay, e raised to the power sine inverse x, okay, this is our first line for any question. Now differentiate with respect to x. Differentiate with respect to x. If we forget to write this line, then examiner must have right to deduct our marks. Differentiate with respect to x, so derivative of y is dy by dx. dy by dx. dy by dx, and the derivative of e raised to the power sine inverse x. This is an example of exponential function. Here power is sine inverse x, and the base is what? Base is e, which is a constant. Okay, so derivative is, we already discussed, the derivative of exponential function means derivative of function. Look at this function, e raised to function, e raised to the power function as it is, and the derivative of a function. Okay, so take this step, e raised to the power sine inverse x as it is, e raised to the power sine inverse x as it is. Okay, and multiply by derivative of dot derivative of sine inverse x, and the derivative of sine inverse x is 1 by under root 1 minus x square. Is it clear? Derivative of sine inverse x is just 1 upon 1 minus x square. This is our answer. So simple. Okay, look, the given function is sine e raised to the power sine inverse x. Okay, so first we differentiate the function, because there is no power is 1 of this function. Okay, so we need not to solve the power. If power is other than 1, like 2, 3, 4, 5 and so on, then we first solve power. We just multiply the given function by its power and reduce power by 1, then follow these two steps. Okay, so here first of all, we differentiate e raised to the sine inverse x means function as it is, e raised to the power sine inverse x. Then the derivative of sine inverse x is 1 by root of 1 minus x square. Okay, so look at some other questions. Question number 2. This is the fifth question of NCERT exercise number 5.4. Okay, we directly use solution of that question, because we first write the question in our solution. Let y is equal to, let y is equal to what? Log of cos e raised to the power x. Log of log, log of cos with angle e raised to the power x. Cos with angle e raised to the power x, e raised to the power x. Okay, next differentiate with respect to x. Differentiate with respect to x. Listen, the given function is an example of log function. Okay, so the differentiation of log function is what? 1 by function, 1 by function and derivative of a function. Okay, is it clear? 1 by function and a derivative of a function. Here the function is cos with angle e raised to the power x. So differentiate with respect to x. So first of all, derivative of y. Derivative of y is dy by dx, which is equal to what? 1 by function, means 1 upon cos with angle e raised to the power x. Cos with angle e raised to the power x. Is that clear? Dot derivative of function, derivative of cos means derivative of cos x. Here derivative of cos x is minus sin x, so our result will be minus sine, and the angle as it is, means e raised to the power x, e raised to the power x. E raised to the power x. Okay, now derivative of e raised to the power x is what? E raised to the power x. Listen, here we we follow the rules of differentiation. First power, then function, then angle. Okay, here power is 1, so no need to solve the power. The function is log, and the derivative of log is 1 by 1 by function and the derivative of function. Okay, function is cos, and the angle of cos is e raised to the power x. So first we write derivative of cos x, which is minus sin x. Okay, then power derivative of angle is e raised to the power x, and the derivative of e raised to the power x is e raised to the power x. Is that clear? Okay, now consider another question. Question number 3. This is the 7th question of NCERT textbook, exercise number 5.4. We know there is no need to write the question because solution already start with the question. Okay, let y is equal to let y is equal to, given question is under root e raised to the power root x, under root e raised to the power root x, under root e raised to the power root x. This is the given question. Under root e raised to the power root x. So first line is differentiate with respect to x, WRT with respect to x. Never forget to write this line because it deduct our marks in final exam. So derivative of y is dy by dx. Okay, now look at the question. E raised to the power root x, and the whole power is 1 by 2. Okay, we already discussed, if we want to differentiate any function which contains root function, derivative of root function is 1 by 2 root function as it is, and the derivative of function means listen, 1 by 2 root function. So 1 by 2 root function as it is, root means root of e raised to the power x. E raised to the power, listen, e raised to the power root x. So here is e and here root x. Is that clear? Listen and look. 1 by 2 root of e raised to the power root x means 1 by 2 root function. Okay, 1 by 2 root function as it is, dot, and the derivative of function means e raised to the power x, derivative of e raised to the power root x, and the derivative of e raised to the power root x is same, e raised to the power root x. So here e and the power is root x. Power is root x. Now we need to solve the power also, because derivative of root x also exists. So what is the derivative of root x? It's also 1 by 2 root x. Is that clear or not? Because the function which is in form of root, the derivative of that function is 1 by 2 root function, and here function is x, and the derivative of x is 1, so no need to solve further. This is our answer. Okay, just try to understand the steps used in the solution. 1 by 2 root function into derivative of the function. Is that clear? Okay, now consider another example, question number 4, and this is the sixth question of NCERT textbook exercise number 5.4. Okay, so we not need to write question, because the solution will start with the question. Okay, so start our solution. Let y equal to, let y is equal to e raised to the power x, e raised to the power x, e raised to the power x, plus e raised to the power x square, e raised to the power x square, e raised to the power x square, x square, plus e raised to the power x cube, e plus e raised to the power x4, plus e raised to the power x raised to the power 5. e raised to the power x raised to the power 5. X 5. This is the given question. Okay, next line, differentiate with respect to x and the derivative of y is dy by dx. Okay, and the derivative of e raised to the power x is same, e raised to the power x, right? E raised to the power x plus, and the derivative of e raised to the power x square, this is also same, plus derivative of e raised to the power x square is also same, e raised to the power x square. But here we need to solve x square because derivative of x square also exists. So derivative of x square is 2x. We multiply x square x by 2 and reduce power by 1. 2 minus 1 is 1. So derivative of x square is 2x. Plus next term will be e raised to the power x cube. Next e raised to the power x raised to the 4. Next e raised to the power x raised to the power 5. Okay, so we write all the terms. So next term is e raised to the power x cube, and the derivative of e raised to the power x cube is also first is same, e raised to the power x cube. But derivative of x cube also exists. So derivative of x cube is 3 x square, 3x square, because we multiply the x by 2 and reduce power by 1, which becomes 2. So derivative of e raised to the power x cube, which is the second term, third term of the given question. Okay, now derivative of next term, which is e raised to the power x4. Then the derivative of this term is also e raised to the power x4. And the derivative of x raised to the power 4 is 4x cube. Okay, 4x cube. Now I think you solve or differentiate x raised to the power x raised to 5 by yourself. Its answer will be e raised to the power x raised to the power 5 into 5x raised to the power 4. Okay, so write yourself. Is it clear? Now next question. Question number 5. This question is from exercise number 5.5 of NCRT textbook question number 1. Okay, differentiate cos x into cos 2x into cos 3x with respect to x. So our solution will start without right question, because solution also contains questions. So y equal to cos x cos x dot cos 2x dot cos 3x cos 3x. Okay, look friends, here question contains three different functions as a product. Okay, so here first of all we simplify the given question. Okay, so our first step in this type of question is taking log both sides. Taking log both sides. When we take log both sides, then our question become log. Sorry, we write natural log. So we use a table log e log e and here y. Okay, equal to log e, then cos x dot cos 3x dot cos, sorry, here we mistake, his angle is 2x and the angle of last one is 3x, cos 3x. Is it clear? So log y is equal to log cos x, cos 2x and cos 3x. We paste our question here. Let y is equal to cos x, cos 2x and into cos 3x. This is the given question and we start our solution by taking log both sides. So our solution will become log y is equal to log cos x cos 2x cos 3x cos 2x cos 3x. Okay, bracket close. So now differentiate with respect to x, with respect to x. So the derivative of log y, first of all we differentiate log, and the derivative of log is 1 by function. So here 1 upon y, 1 upon y into dy by dx, because derivative of y is dy by dx. Sorry, listen students, before differentiate the function we first so sorry. We first when we take log both sides, then first simplify the given question. Yeah. And here we use some law of logarithm. Log x into y means log x plus log y. So here in the given question there are three functions. There are three functions which are in log form. Okay, so the simplified form of a given term is log y log y is equal to log cos x plus log 2x log cos 2x cos cos 2x. Okay, plus log cos 3x log cos 3x cos 3x 3x. Is that clear? Now differentiate with respect to x. Okay, now the differentiation of a given question is so simple. Okay, so look, listen, no matter the question contains how many terms. Okay, if there are four terms, then we put also post plus sign, then separate four terms. Okay, and if there are 5 terms, then we further separate the given terms. No matter. Now differentiate with respect to x. Differentiate with respect to x. So first of all, derivative of log y is 1 by y. Derivative of log y is 1 by y, 1 upon y, and the derivative of y is dy by dx. Derivative of y is dy by dx. Is that clear? Okay, equal to, now derivative of log cos x means 1 by cos x, 1 by cos x. Is that clear? And the derivative of cos x is minus sin x. Derivative of cos x is minus sin x. Is it clear? Plus derivative of cos 2x, same, 1 by cos 2x, 1 by cos 2x. Dot, and the derivative of cos 2x is minus sin x, minus sin 2x. Okay, no need to touch the angle is as it is. Now last, the derivative of 2x is 2. Okay, just follow the rule power function angle with full concentration. Okay, and your answer never be wrong. Now derivative of log cos 3x is what? 1 by cos 3x, 1 by cos 3x, 1 upon cos 3x, cos 3x, and the derivative of cos 3x is minus sin 3x, sin 3x, and the derivative of 3x is 3. Okay, now our answer will become, now dy by dx is what? Left dy by dx in left hand side. Okay, and take y in right hand side from left hand side. So y into minus sin x by cos x is what? Minus 10x, minus 10x, right? Okay, next sin 2x by cos 2x minus 10 2x, 10 2x, and 2 is also here. 2, 10, 2x. Is that clear? Okay. Next, minus 3, 10, 3x. This is our answer. Just put value of y at the place of y, and the value of y is cos 3x, cos x, cos x dot cos 2x, cos 2x dot cos 3x, cos 3x, multiply by minus 10x minus 10x minus 2, 10 2x, 10 2x minus 3, 10 3x, 10 3x. Okay, so this is our answer. Now we can able to solve the different kind of questions which contains a complex function. Okay, complex function means which a function which contains two or more than two kind of functions. Okay, so here we considered another important example question. Here we discuss a question it's fourth question of 5.5 exercise. Okay, so we start with solution because we write our question in solution. So let y equal to x raised to the power x minus 2 raised to the power sine inverse x. X raised to the power x, x raised to the power x minus 2 raised to the power sine x, sine inverse x, 2 raised to the power 2 raised to the power sine x. Look students, here question consists two different functions. First x raised to the power x and second 2 raised to the power sine x. Okay, so put y equal to u plus 3 minus v. Okay, so dy by dx become dy by dx is what equal to, I think, du by dx minus dy by dx. Du by dx. minus dv by dx dv by dx. This is our first equation, equation number 1. Now first of all we find du by dx from u, and the value of u is what? U equal to x raised to the power x, x raised to the power x, x raised to the power x. Okay, so given function in the form of a function raised to the power function, function raised to the power function, and we solve this concept by taking log both sides, taking log both side. Okay, so our equation will become log u is equal to log u log of x raised to the power x. Is that clear? Log x raised to the power x. First of all, simplify the given equation by apply law of logarithm. Log u is equal to log x raised to the power y. We discussed already. Okay, and the simplified form of this type is what? X log x, x log x. We already discussed. Okay, if you don't understand, then watch video once again by starting. Right, then your doubt will be cleared. So log ex. Now differentiate with respect to x. Differentiate with respect to x, and the derivative of u is what? 1 by u, 1 by u into derivative of u is du by dx, du by dx, du by dx. Okay, and here in right hand side we use product rule. Product rule means first as it is means x as it is, and derivative of log x, and the derivative of log x is 1 by x. We already discussed 1 by x, 1 upon x plus, now log x as it is, and derivative of x is what? 1. That's the result. Log x as it is, and the derivative of x is 1. Now the value of du by dx, value of gu by dx is equal to u dot here x cancelled by x, and our result become 1 plus log x, log x. Is that clear? Okay, now place value of u at the place of u, which is x raised to the power x. So value of dy by dx, value of du by dx become 1 e raised to the power x dot 1 plus log x. Okay, now here we find the value of dv by dx. We find dv by dx, v is equal to what? 2 raised to the power sine x, 2 raised to the power sine x, 2 raised to the power sine x, and the differentiation of this term is what? Just differentiate with respect to x, differentiate with respect to x. Derivative of v is what? dv by dx. Derivative of v is dv by dx, dv by dx. By dx equal to the derivative of a raised to the power x, a raised to the power x, because this is kind of a exponential function. Here base is 2, which is a constant, and the variable or a function is taken as a power of 2. Okay, so the given function is a exponential function. So the derivative of a exponential function means a raised to the power x is a raised to the power x into log a, means 2 raised to the power sine x, 2 raised to the power sine x, sine x into log a, means log 2. Is it clear? Log 2. Now derivative of sine x. Okay, we must differentiate sine x also. So derivative of sine x is cos x. This is the value of dv by dx, 2 raised to the power sine x into log 2, okay, into cos x, and the value of du by dx. We write value of du by dx here, du by dx equal to x raised to the power x, because we put value of u at place of u, and the value of u is x raised to the power x, x raised to the power x dot 1 plus log x log x. Okay, so put value of du by dx, put value of du by dx and du by dx and d and dv by dx. In first equation, in equation number first, so we will get dy by dx. Okay, and the value of dy by dx which will we get is x raised to the power x into 1 plus log x minus 2 raised to the power sine x minus log 2 into cos x. This is our result. Okay, so we can easily solve these kind of questions by just convert them into standard form. Okay, and our solution will be easy. Okay students, so try some questions of exercise number 5.5, 5.4, 5.2. okay, the next concept and some questions will be discussed in next class. Okay, so thank you for today. Have a nice day.